right, guys, let's check out page 3. Let's see, 40, I think we were on. Sounds good. All right, so we're going to wrap up this section today on solving exponential and log equations. Yesterday we looked at exponentials. Today we're going to take a look at logs. And it's kind of a similar process because after all, logs and exponentials are inverses of each other. They cancel each other out. So we'll check some of these out today. So kind of big things so far that we've been discussing in this unit. Maybe you can complete some of these statements for me. Let's see, logs are powers, okay? And yesterday we were looking at if we wanted to move a base to the other side of an equation, what did that base become? If you want to move a base, it becomes a let's see, maybe we'll do a quick example. If we have 2 to the x plus 3 equals, I don't know, 1. We'll just make this up. If you wanted to move that 2 to the other side, that way you can start to solve for x, what would that 2 become on the, on the other side? Yeah. Okay, if you want to move a base, it becomes a log. Just like if you want to move a -2, you'd have to add it to the other side. Those are inverse operations. If you want to move a base, it becomes a log. What if we wanted to go the other way? If you want to move a log, it becomes a... Can we go the opposite way? If you move a base, it becomes a log. If you move a log, it becomes a base. We're going to see that today. All right, so yesterday we were moving bases to the other side because those were exponential equations. Today we're going to take a look at logs. Maybe we want to move those to the other side. All right, now we've already kind of discussed how to solve particular logarithmic equations. That's specifically when we can get one log on both sides. So maybe we'll review that idea with this example, and then we'll get into some different kind of log equations. So in this first one, how might we be able to get one log on the left and one log on the right? Can we utilize some properties? What do you think, Kyle?
Multiply the x into the x plus 2.
All right, if we're adding 2 logs together that are exactly the same, they're both natural logs, we can multiply the arguments together. So that would be an x squared plus 2x. I think we did this on Friday last week. So we can utilize those properties, get one log on the left, one log on the right. Now that we have one log on each side, where can we go from there? According to this equation, you're saying the left-hand side and the right-hand side have to be exactly the same. You want to keep going? Maybe?
It's like arguments equal to each other.
Good. Okay, notice how we already know the natural log on the left and the natural log on the right are exactly the same. Those match. So we just need to test when are the arguments the same. All right, so for my procedural people, maybe we'll write down kind of the steps that we've done so far. So if you have logs on both sides, we want to go ahead and use the properties to get one log on each side. After we did that, we noticed the logs would cancel each other out because after all, we know that they're exactly the same. So we were able to equal the arguments together. And last but not least, we're just going to use some algebra to help us solve for x. So where do we want to go from there? Now that we have x squared plus 2x equals 8. Anything kind of jump out at you? What do you think, Summer? That way we can factor. Good. Okay, so we'll set it equal to 0. Two numbers that multiply to -8 but add to 2. Let's see, +4, -2. So what are our x solutions? Yeah?
2 and -4.
2 and -4. All right, so that's what factoring gives us. Do we want to check our work? Do we trust that both of those are solutions? Say it again.
We can all use the x equals 2.
Why not the -4?
Because you can have it.
Because this is negative? What was the next statement you just said after that?
You can't have it like a log.
You can't have a negative argument, okay? If you were to take these solutions and plug them back in for any x's up top, we cannot have a negative argument. What also can't we have in the argument? 0. Good. Okay, so we got to double check it. I don't care that this x value was -4. It can be negative. I care if it makes the argument negative. Okay, there's a difference there. So in the end, we always got to check if a solution makes an argument negative or 0. Okay, we definitely got to check our work for these log equations because we kind of have this restriction. So basically, we're just looking for values that would make the arguments be positive. All right. How is that equation? Kind of a reminder for us, I guess, from Friday. Get 1 log on each side, go from there. Okay. We're going to check some out today where we cannot get 1 log on each side, maybe because we only have 1 logarithm in the entire equation. Notice how in this one we were able to get 2. So if we only have 1 log expression for my procedural people, the steps are going to be pretty close to what we did yesterday. Remember yesterday we isolated the exponential part of the equation? Well, if we're working with logs today, we're going to isolate the log portion. Yesterday when we were working with exponentials, after we got the exponential by itself, we converted it to a log. Well, today, if we're isolating a log, we're going to convert it to an exponential. And last but not least, after we convert it, we should be easily able to solve for x. So we'll check some of those out today. But let's see, in the end, if none of these kind of processes or algebraic steps work, what should kind of be our last resort? If we can't solve it by hand? No. We're not going to give up. We're not going to cry. We're not going to quit. We're going to graph it. Yep. Okay, graph to find intersection. If all else fails, we try that. If we have a calculator. So we kind of need that stipulation. All right, so let's just go ahead and try to practice some of these log equations today. Some of them are going to be similar to the ones we did on Friday, like if we can get 1 log on the left, 1 log on the right, but other ones we might not be able to do that. So we're going to kind of practice those types of equations. Let's check the first one. Can we utilize a property of a log? If you check out the left-hand side. Yeah, which one do you want to use? Bless you. Division. All right, so log base 2. We're going to divide the arguments, x plus 2 over x minus 1. And it should equal 3. All right, so this one's completely different than the one we just did at the beginning. Okay, the one we did before, we were able to get one log on the left, one log on the right, boom, we were good to go. This one, we have one log on the left and just the number 3 on the right. So somehow, we're going to have to solve this one a little bit differently. If we just have one log in our equation, we're going to try to convert it to an exponential. So, in your head, if you wanted to try to get these x's all by themselves, you're used to moving things over to the other side of an equation using an inverse operation. If we want to move this log with a base of 2 to the other side, that way we can get the x plus 2 over x minus 1 all by itself. What do you think the log would turn into when we move it to the other side? 2 to the power of 3. When you move a log with a base of 2 to the other side of an equation, it becomes an exponential with a base of 2. Okay, the inverse operation. So I think we can go from here. We'll have x plus 2 over x minus 1 equals 8. Notice how the moment we converted it to an exponential, okay, we moved the log to the other side, we should be able to use some easy algebra to go from there. What do you want to do? Okay, what do you want to multiply over? What do you want to multiply? You said multiply. X minus 1. Alright, so x plus 2 equals 8x minus 8. We got to distribute that 8. And subtract the 7, add the 8. Or sorry, subtract the x, add the 8. So we get, looks like 10 over 7. We gotta check this, okay, because we're dealing with logs, we kind of have that restriction. If you were to plug in 10 over 7 into the arguments at the top, would they be positive? I think we could try to check this without a calculator, right? 10 over 7 plus 2, that's positive. 10 over 7 minus 1, that's still positive, right? So this is our solution. It doesn't make any argument negative or 0. All right, let's try the next one. We have natural log on the left equals a natural log on the right. What do you want to try? Gary?
Just do x plus 2 equals 2.
Yeah, we already know the natural logs are exactly the same, so we'll just set the arguments equal to each other. This one's too simple. We get x equals negative 1. I got a negative answer. Does that mean no solution? No. We got to check it. Does it make the argument negative? If you plug in negative 1, it would be 2, which is positive. Okay? So be careful. I don't care if the answer is negative. I care if the answer makes the argument negative. Let's try the next one. All right, so we have one log in our equation. We're going to try to get that all by itself. Maybe we'll move over the negative 3. So we'll get 4. If we're trying to solve for x, we want to move over the log base 3. So if we're moving a log, what does it become? 3 to the power of 4, right? It becomes an exponential. The base is 3, the power is 4. Good. So 3 to the 4th is 81. Add 1, divide 2. We have 41. You gotta check it. Is the argument positive? Yep. So we're good to go. Do you guys want to try the next one on your own? Try the bottom left. See how you do?
But that's for you also I was gonna show you what's score in the body. I mean, maybe not that one.
G- Gary for the score, Kyle for the assist.
Yeah.
Right.
I didn't know I had a comment. I ain't some.
All right, let's check it out.
Fraud.
What'd you guys do? Bottom left. Yeah?
I multiplied x into the x plus 3.
Okay, adding the same logs, you can multiply the arguments. That's a good first step. Where'd you go from there? Get rid of the logs. We already know they're exactly the same, so let's check out the arguments. When are those the same? Why do you want to subtract the 10? So we can factor. All right, two numbers that multiply to negative 10. Add to 3. Negative 5 and 2. So our solutions, 5 and negative 2. Are we done? No. Why is it just 5? Right. That solution makes an argument negative.
Isn't it?
Oh, is it the other way?
It's positive 5 negative.
Mario. Huh?
Or I mean,
Well, I
like
was
it's
just looking at negative
x plus 5.
Negative.
Oh, we got him flipped up. There we go. I knew those were the right numbers, just the signs was in my head. Okay. So negative 5, 2. So then that would make 2 the solution and negative 5 the not solution. That's okay. How'd you do?
Awesome.
Awesome?
Easier than the big question.
You think?
I think.
Well, then maybe we'll check out some of the ones that we did yesterday. More practice for this. Okay? Do you guys want to try the next one? Are you on a roll? Keep going? Bless you. All right, let's check this one out. Property on the left. Bless you. What'd you do? We turned 2 logs into 1. We divided. Good. And 2 logs on the right being subtracted. Also divide, right? Logs match. Gone, gone. Okay. Bless you. Cross multiply. I'll never forget this, okay? My elementary school teacher, middle school teacher, whenever we learned cross multiplication, She always referred to this as the butterfly method. Kind of cute when you're in elementary school, okay? Maybe a little corny when you're in high school, but still memorable nonetheless. The reason I remember this is because when I was younger, I always got mixed up, like, what do you do when you multiply fractions? What do you do if your fractions equal to each other? What do you do if you're adding fractions? Like, you have all these different rules. And for some reason, I always remembered cross multiply was when fractions are equal, because the equal sign was always kind of on the chest of that butterfly. For some reason, it stuck with me. Okay, so cross multiply to me will always be the butterfly method. So we'll get 7x minus 21 equals 3x plus 3. And let's see, subtract the 3x, add the 21. We get 6. Okay? Does it work? Yes. When you plug it in, it makes the arguments positive. Perfect. You want to go for the gusto, the trifecta? Try the last one? All right, let's see. Did we add over the 3? Yeah? If you want to move a natural log to the other side, what does it become? E squared. Good. We can add the 1 and then divide the 2. There's your solution. It looks weird, okay, but that's still your solution nonetheless. Okay, it's actually an exact answer because you have an exact fraction. Did anybody type that in and get a decimal? Just 4.195. All right, so if you wanted to check your work, maybe plug in that decimal into the argument. Is it still positive? Yes, so we're good to go. How are we doing with log equations? Good? Okay. Let's do more practice with the exponentials from yesterday, okay? On the back of that page, go ahead and divide this into like 4 sections. We'll do 4 examples. On the back of that one. 342, yeah. 342, just on the back. Let's try this one. We want to solve for x. What do you want to move over first? Divide by 3. You want to solve for x. What do you want to move over next? We want to move the 2 over, right? That way we're just left with x minus 1. But that 2 is a base. If you move a base, it becomes a log. So this would be log base 2 of 4. Yeah.
Did you just make the 4 to the power of
Let's change it to 18. Divide by 3, we would get 6. Move the 2 over, or the base of 2 over, it would become a log with a base of 2. Solve for x, we can add the 1. So log base 2 of 6 plus 1. If you move a log, it becomes a base. If you move a base, it becomes a log. Vice versa. Okay? Let's try this one. You could type this into your calculator. Okay, log base 2 of 6 plus 1. You'd have to do log of 6 over log of 2, but you could still get it to be as a decimal if you wanted to. How do you want to solve for x for this next one?
That over 7.
Let's add over 7. What do you want to move over next? The e. If you move e, it becomes a natural log, right? You move a base, it becomes a log. Solve for x. Natural log of 16 minus 3. You could type that in and get a decimal if you wanted to. You want to solve for x. What do you want to move over first? Let's divide the 7. What do you want to move over next? It's a base of 3. You move over a base, it becomes a log base 3. Then what? Are we done? Look at it carefully.
No, it's no solution.
Why?
Argument's negative.
The argument's negative. Be careful. Some of you are going to get into a groove with these. You're just going to keep going and going and going. Okay, you got to check your work. Take a look at it. And let's try the last one. What do you want to move over first? Let's subtract the 5. Then divide the 4. Then move the e over, it becomes a natural log. And then move the negative. Is that our solution? Argument's positive, right? So we know we're good to go. Those 4 examples are basically what we did yesterday. Are they still as bad?
On the homework,
Mhm.
for number 2, would you have to do the bracket calculator?
Yes. Because there's no way you can get 3 and 5 to be the same base. All right. Complete these statements for me. Logs are powers. You move a base, it becomes a... You move a log, it becomes a base. I'm going to hammer it into you guys. Sounds good. All right, we're done.